Greetings everyone. Today we're going to explore rate of change, specifically of linear functions. Now you most commonly know rate of change as slope. Make sure you have your foldable for this one. Now as you can see on your foldable, we're going to talk about slope in 4 different ways. Now finding slope can be presented to you in our class in these different ways. So we need to be okay fluidly going between an equation, 2 points, a graph, and a table. Let's start off on the front of our notes that say from an equation. The key piece that I want you to identify here is M. M represents slope. And you'll notice that when y is isolated, right? You're going to have to isolate y. When y is isolated, I care about the number that's in front of x. We call that the coefficient of x. Let's take a look inside at our 4 examples. First thing, we need to make sure that y is isolated, and it is. Next, we want to identify what is the coefficient of x. The number being multiplied by x, in this case, is 4. So m equals 4. Let's take a look at the next example. This one's a little confusing. There is no y. There's an x, and the x isn't even solved. So instead of times 4, let's divide both sides by 4. If I isolate x, I get x equals 2. There's not even a y here. So let's talk about this equation. First, let me think of it like a graph. If I was to graph and maybe sketch this out, right? If I went to the x-axis and I said slice the x at 2. Remember, that would be a vertical line. A vertical line could have dots all along here. So if I talk about rise over run, it's going to be some number, but I'm not running. I'm not running. And I can't divide by 0. Plug that in your calculator once. Try 6 divided by 0. You get an error, right? What that means is, and here's where you got to work on this one, my slope is undefined. All right? We cannot divide by 0. So 3 ways to think of it. If you're a good memorizer, here's what you're going to do. Every vertical line has a slope of undefined. Great. I'm not a good memorizer, so I want to think of it mathematically. If I count on a graph, rise 3, run 0. Plug it in my calculator, I get an error. If the calculator gives you a word, you need to write down a word. And let me give you the ultimate little trick. Stick figures. Can you walk straight up a wall? No. So therefore, it's unique, it's special, and so we're going to say the slope is undefined. Let's take a look at the next 2 examples. In this one, I see I have a little bit of work to do to isolate y. Remember, if you need help isolating a variable, see my literal equations videos. If I look at the y, it's being multiplied by 2. So I need to go and divide every piece by 2. So y equals, technically this is a negative 1 over 2. It's going to remain a fraction. And we get a nice clean 5. Now that y is isolated, the value that's in front of the x, the coefficient of x, is negative 1/2. Let's take a look at this one. I see I have some simplifying to do. First of all, I need to combine like terms. 3 y's subtract 2 y's leave me with 1 y. The plus 6 and 15 fall down. Well, let's kick the 6 over. Instead of plus 6, let's minus 6. That gets me to 9. So I've isolated y, but if I was to ask you what number is in front of x, there is no x, right? So option 1. What number could be in front of x that would make it disappear? A 0, right? A 0 would make the x disappear. So my slope is 0. Now, to be honest, it's not often thought of like that. So let's approach it another way. If I was to do a quick sketch and slice the y-axis at 9, Y equals a number is a horizontal line. If I count my rise and my run, my rise is 0, my run is, I don't know, some number, whatever number you want to count, right? 0 over any number is 0. Or let me throw my trick at you, Stickman. A horizontal surface has no slope. No slope means 0. So there's different ways to remember this or think about it. And what I need you to do is find what works for you. Are you a good memorizer? Memorize it. Are you a good drawer? Draw it out. Do stick figures help? Then let's make it work. Let's flip back to the front of our foldable. Now we're going to talk about from a graph. This is the one that if you're in my Algebra 1 class, you're most familiar with from a previous year. And we're going to circle rise over run. We want to count our rise and count our run. We're going to count boxes and create a fraction. All right, let's talk about this first example. In this picture, I'm going to count from one dot to the next. I'm rising 1, 2, 3. I went up 3. I'm running 0. I'm running 0. So if I create rise over run, positive 3 over 0, you can't divide by 0. That's not possible. And so our slope is going to be undefined. I can't divide by 0. Or if you're a good memorizer, you're going to memorize every vertical line has a slope that's undefined. Or if you thought maybe my little stick figure was helpful, can you walk straight up a wall? Nope, undefined. Let's take a look at the next one. You'll notice that it's also special. In this case, I am rising 0, right? I'm not going up or down at all. Let's talk about our run. Our run is 1, 2, 3, 4, 5. 0 divided by 5 is 0. If you're a good memorizer, every horizontal line has a slope of 0, or if stick figure helps, it's a flat surface, it's a floor. Every floor has a slope of 0. Let's take a look at slanted graphs, right? If I'm walking left to right, I would say my stick figure man is going down the line, decreasing, negative slope. So I know I'm going to have a negative slope. But let's actually count this out. Pick a dot. I'm going to pick, I don't know, this dot, right? Rise over run. Rise. To get to the next dot, need to go down 1, 2, 3, 4. Down 4. That's a negative. Negative 4 is my rise. Let's talk about my run. 1, 2, 3, 4, 5, 6. I had to go 6 to the right. That's a positive 6. So let's talk about this. A negative divided by a positive is a negative. But 4 over 6 doesn't divide nice, but it does reduce. 4, 6 reduces down to 2/3. Negative 2/3 is my slope. Let's take a look at the next one. Let's talk about rise over run. I am going to rise. I'm going to start at this dot here. I'm going to rise 1, 2, 3. I went up 3. That's a positive 3. Then I'm going to go to the right 1, positive 1. Positive 3 is my rise. Positive 1 is my run. 3 divided by 1 is just 3. Positive 3. If you can divide the numbers, you need to. That's how we simplify values. Alrighty, let's flip back to the front and take a look at from a table. From a table, to be honest, I tend to find a little bit easier. But let's talk about a few things on the front here. Can you please box this ratio? You're familiar with rise over run. You know that rise is going up or down, therefore rise is your y's. So notice I have y over x. That makes sense. Let's talk about this symbol here. This triangle symbol is called delta. Now delta means change. So I'm talking about what's the change in the y values over the change in the x values. So calculating y's won't be a problem, but what you need to remember is which value is in the numerator and which value is in the denominator. So let's take a look at our examples. When you're given a table, you get to choose which values you're going to compare. And so if I take a look, I'm going to look at these values because when I look at them, I want to deal with positives. Positives are easier. So if I take a look at the change, what I'm seeking is what is the change from 4 to 2. If I go from 4 to 2, I'm subtracting 2. Well, let's take a look at the other side. If I jump from 9 to 15, my change is positive 6. So what you need to concentrate on then is which value is in the numerator. The change in y over the change in x. Y change is in the numerator. Let's break this apart now. A negative divided by a positive is a negative, and 2/6 reduces down to 1/3. Let's look at the next one. I'm going to try something different. You know what we're going to do? I'm going to jump from here to here. If I jump from 5 to 9, that's a +4. If you choose that on the right, just choose that on the left. If I jump from 5 to 5, that's +0. So you can choose your jumps. Just make sure you pick the same jump on both sides. Which number is in the numerator? In this case, we are talking about, oops, sorry, my pen there went a little crazy. Let me fix that. We are talking about the change in y over the change in x. That means +4 is in the numerator and 0 is in the denominator. I cannot divide by 0. That's not okay. And we have a word for that. That means my slope is undefined. Let's take a look at this table. I'm going to show a different jump. I'm going to jump from here to here, just because. If I jump from 150 to 200, that's +50. All I need to do is be consistent on the other side of the table. 42 to 54 is +12. If I choose, be careful here, it's supposed to be change in y over change in x. That means 12 is in the numerator and 50 is in the denominator. 12 over 50, we can reduce that fraction. 12 and 50 can both be cut in half. That leaves me with 6 over 25. Okay, my slope is 6/25. Let's take a look at this next one. My jump is 0, and my jump here is subtract 3. Change in y over change in x. 0 divided by any number is 0. Now, if you're struggling with the special fractions, make sure to check out your calculator, right? Your calculator will remind you of those special rules. Your calculator also reduces fractions, so if you need help with that, let me know. One last topic, jump to the front. We're taking a look at from to points. So here's where you have to use a formula. So let's talk about this. On the front, can you please box this right here? Now, if you look at other videos, you'll notice that they put the little sub numbers here, right? They'll have a little 2 and a little 1, a little 2 and a little 1. That can be helpful, but you also kind of don't need it necessarily, right? Like we need to take the y values, subtract them. We need to take the x values and subtract them. When we talked earlier about how this meant delta, delta means change. If I'm trying to find the change between two numbers, I'm subtracting them. Change and difference are the same operation. We're subtracting to find the change. Now, if we jump inside, here's the one thing I really think you all should do. I think you should label xy, xy. I know you already know that, but I promise you it'll help in this process. Let's talk about our formula. Our formula is a big fraction bar, and we are subtracting values. We're finding the change. I personally like to set it up first, okay? Now, in the numerator, rise over run. Rise is y's. I have this y, and I have this y. You see how I filled that in? Okay, let's look at the denominator. I need to go in the same order. I have this x, and I have this x. See how the 5 and 1 came first? They came first. That's the pattern here. So what I mean by that, really quick, is if you chose a different number first, if you went -7 then -5, that's fine. You would just do -2 then -1, right? You can have it flip-flopped from what I have. We should still get the same answer. All right, let's reduce. -5 subtract -7. That's the same as saying -5 plus 7, which is 2. -1 subtract -2 is the same as -1 plus 2. That's a positive 1. Use your calculator if you need help, but 2 divides by 1 perfectly. All right, y's over x's. So let's take a look. My y value, my y value. My x value, my x value. Let's calculate. 7 subtract 3. -1 subtract 5. A positive divided by a negative is a negative, and we can cut both of these down. We want to reduce our fraction to 2/3. Let's take a look at these two. Let's set up. We are finding the change in y's over the change in x's. Change in y over the change in x's. I promise you labeling xy, xy will be helpful. The change in y's goes on top. The change in x's goes on bottom. 3 minus 9, 4 minus 4. Uh-oh, I can't divide by 0. That's not okay. That's no go. So we need to write undefined. Next example, y subtract y, x subtract x. -6 subtract -6 becomes -6 plus 6. That's 0. 5 subtract -2 is the same as 5 plus 2. That's 7. 0 divided by 7 is 0. So be very careful with these special ones. In this lesson, I'm asking you for the slope. The equation of the line is different. Equation versus slope, two different things. All right, so one thing I suggest doing is if you were writing notes this whole time, I strongly recommend going through and re-listening to this video without distractions, without your phone, without writing anything. Just listen and watch to really absorb, especially those unique slopes of 0 and undefined. As always, make sure to check out Google Classroom to see what your task is to go with this instruction. And let me know if you have any questions on these notes. And until next time, have a good one.